5-axis probe system has additional two rotary axes, A axis and B axis, along with XYZ motion given by the CMM structure. This allows the CMM to move at constant velocity in a single vector while measuring. As the probe head is much lighter and more dynamic when compared to the CMM structure, it is possible to quickly follow changes in the part geometry without introducing harmful dynamic errors. This results in much faster surface speeds and hence shorter measurement cycles. 5-axis scanning technology allows the user to achieve extraordinary levels of throughput. Now you can observe a motorized 5-axis probe head here. This is the probe head, and appropriate styluses can be inserted into the probe head. We can observe here that apart from XYZ motion given by the CMM structure, these motorized probe heads they have their own A-axis movement as well as B-axis movement. So the stylus can be swiveled as shown here, and the stylus can rotate in plus 180 degree or minus 180 degree. Apart from that, a radial adjustment is also possible. There is an integral LCD display which enables easy programming of probe orientation. So depending upon the inspection requirement, the probe orientation can be adjusted. And this is the digital display built into the probe head. Now I can see here with the use of extended extension bars, probe head can reach to deep holes and recesses, and the internal details, deep hole details can be measured. An accurate 3D form measurement even with long stylus is possible. You can see here by using the extension bars, the measurement volume can be selected. Now, apart from single stylus probe heads, multiple stylus probe heads are also possible. You can see here we have a probe head with multiple stylus. This is a disc stylus with an extension bar, and this is a ruby ball stylus with the knuckle joint. Similarly, we can insert appropriate stylus here depending upon the inspection requirement. A wide range of styli have been developed to suit many different gauging applications. These can be mounted on multiple stylus head. The selection of the stylus is done based on the application for which the probe is to be used. Now you can see here with the help of motorized probe head, infinite number of repeatable positions and repeatable stylus changing is possible. You can see here a motorized 5-axis probe head is fixed to the Z-axis. It can orient its angle can be adjusted depending upon the workpiece inclination, workpiece angle. Here also you can see the inclined surface and bore is to be checked. So the 5-axis heads will help in inspection of these holes which are at some inclination. Advanced probe head increases inspection throughput up to 3 times using fast infinite rotary positioning and unique head touch capability. Now, now you can see here, this is the deflected probe body if we use conventional probes, and here we are using a 5-axis scanning type probe. So non-linear motion on a Cartesian CMM induces acceleration and deceleration that twist and deflect the machine structure, and these dynamic deflections result in measurement error. So this is eliminated by using the 5-axis probe system. I can see these pictures show variety of mechanical probes. The motorized probe wherein the angle can be changed, star type probe heads are possible, motorized probe head wherein the angle can be adjusted depending upon the workpiece type. These touch probes are extremely robust, and they are ideal for use on general purpose manual coordinate measuring machines. The feature to be inspected dictates the type and size of the stylus used. However, in all cases, maximum rigidity of the stylus and perfect spacity of the tip are very vital in order to have accurate measurements. You can see here there is excessive deflection of the probe. That means selection of stem of proper thickness and proper length is very important in order to avoid excessive deflection, and perfect sphericity is also very vital so that we get accurate measurements. The performance of gauging can easily be degraded if a stylus is used with poor ball roundness, poor ball location, bad thread fit. See, the fitting of the stylus into the probe body should be proper, otherwise it will lead to improper measurement, or a compromised design that allows excessive bending during measurement. To maintain accuracy at the point of contact, it is recommended that the stylus be kept short. So unnecessary lengthy stylus should not be used, which causes the large amount of deflection, which will lead to incorrect measurement. Joints should be minimized. Between probe and stylus tip, the minimum joint should be there. As large as possible, stylus ball should be used. Now you can see a variety of probes here. This is a stainless steel stem. Ruby tip is ruby tip, and this stem is made of stainless steel, so which is used to measure the recesses as well as the surface heights, widths, etc., etc. Now you can see here a star stylus, and here we are observing how we can use a star stylus to measure the external grooves. So similarly here measurement of internal groove using the star stylus, and here we have a ceramic hollow ball stylus for measurement of diameter of the holes, a disc type stylus, and a cylindrical type stylus used for measurement of threads. Now how do we select the probes? Depending upon the material. See, if you have a soft material, then we should select the probes with low force, low measurement force requirement. So for general use, we can select the SF type, and for heavier, longer and heavier style like we should use the probes with medium force requirement. And similarly for grooves and undercuts, depending upon the type of the inspection, we should select the probes of appropriate length with appropriate force requirement. Now let us see the details of straight probes. Now this diagram shows straight probe stylus. Now this is the threaded portion which will go into the probe body. Different threads are possible, M2 to M6 threadings are possible, and then this is the stem portion. Stems are available with different materials like steel, ceramic, aluminium, carbon fiber, titanium and tungsten carbide, and they are available with different diameters also. And at the end we have the tip. This is the probe tip. Probe tips are available with different tip material like ruby, silver steel, silicon nitride, tungsten carbide, ceramic and zirconia. And tips are available with different shapes also. So this shows a ball type tip, and balls of different diameters up to 6 mm and above are available depending upon the inspection requirements. So effective working length of the probe is D. So the probes of different working lengths are available up to 11 millimeter, 11 to 29 millimeter, 30 to 50 and 50 mm and above. So depending upon the application, we can select probes of different length. Now, straight styli are designed to inspect simple features where direct, unobstructed contact with a measured surface is possible. A tungsten carbide stem provides exceptional rigidity, particularly for styli with small ball and stem diameters. Ruby is regarded as the industry standard for stylus tips. It is one of the hardest materials available, and it is suitable for most applications. Due to adhesive nature, ruby tips are not recommended for scanning aluminium parts. Now, in these pictures show cylindrical head stylus. You can see the tip is cylindrical type, which can be used to measure threads, and this is spherical ended stylus, and then we have datum end. Hemispherical tips are also available for measurement of holes of larger diameter, and then we have star type wherein different tips can be mounted on this probe head. Then we have pointed tips for measurement of threadings, and then extension rods are possible to measure very deep hole details. So extension rods can be used, and at the end we can have the stylus. And adapters are also possible between the probe head and the stylus tip. Now, before we use CMM with selected stylus, we should calibrate whether the probes are